So when we're dealing with related rate questions, we need to understand what kind of diagram that this question is making. So Tamara is getting on this elevator. This elevator is going to go up the outside of a building. Bernice is standing somewhat away from the building. So these two people are actually making a triangle. Looks something like this. The scale isn't important, but what is important is that it's a right triangle. And Tamara is moving straight up the outside of that building. We need to know two pieces of information about all three sides of this triangle. We need to know the length of the sides at the given situation, and we also need to know how each side is changing. So Tamara's elevator, which would be the vertical side, is climbing the building at 3 meters per second. Climbing, moving up, moving in the positive direction. Bernice, she's standing 24 meters from the bottom of the elevator. She's also not moving. So Bernice's change would be 0 meters per second. We also know that Tamara is 45 meters above the sidewalk, so this side is 45 meters. We're being asked to find at what rate is the distance between them changing. So for this diagonal side, we need to know how many meters per second. But in order to do that, we also need to know how long this side is. Well, the good news is this is a right triangle, and we have the Pythagorean theorem. And by doing this, we can see that right now that side is 51 meters. So now that we have all but one of the unknown pieces of information, we can go ahead and actually find at what rate the distance between them is changing. To do that, we need to go back to the Pythagorean theorem. But since this equation only deals with the lengths of the sides and not the rate at which the sides are changing, we need to deal with the derivative. Why? Because the derivative is the rate of change. So, take the derivative of this equation. We have 2a times dA by dt. Keep in mind we're taking the derivative with respect to time. Plus 2b times dB by dt equals 2c times dC by dt. Time to fill in what we know. If we call A the same side that we did before, the bottom side, so A is 24 meters, dA by dt is 0 meters per second. We don't need to worry about units yet, we'll worry about that in the end. B is 45 meters, the change in that side is plus 3 meters per second. C is 51 meters, and we don't know the rate of change of that side. That's what we'll be solving for. Now it's just a matter of doing some simple algebra. 2 times 24 times 0, 0. 2 times 45 times 3 is 270. 2 times 51 is 102. Clean that up. Divide both sides by 102, and it's customary with a related rate question to round to 2 decimal places. So what we have is dC by dt equaling 2.65 units, because this is rate of change, 2.65 meters per second. So those two people are getting 2.65 meters per second further apart.